All right, welcome. Today we're going to be jumping into our next section of content, which is going to be 7.2. We're going to be dealing with proportion. And so let's just jump right into it. Here, again, I've got the notes all on Canvas if you want to download them and kind of follow through as I walk through these notes. But here what we are going to be looking at is just in general what proportion really is. So a proportion states that two ratios or rates are equal to each other. And they're written a few different ways. So you can see it as 3/4 is equal to 9/12. We have 3 with kind of like a dot in between. 3/4 is equal to 9 kind of colon 12. And so the way that you can read these is kind of as follows. You've got 3:4 as 9:12. Okay. I don't know if anyone in this class ever took like an SAT exam, but one of the things on that exam is it's like an analogy. And what it is, an analogy is like saying this is to this as that is to that. It's very growing up, I'll just be honest, I absolutely hated analogies. They were the bane of my existence because I was not very I was not an English person, you know. I didn't really like the topic very much. I kind of leaned more into math, as you can obviously tell. But as I got older and I realized that analogies are basically just mathematical in their kind of idea and their concept, it kind of made a lot more sense to me. And so we have different ways that we identify analogies, okay, or this proportion in this case. The numbers that you read first and last are called the extremes. So in this case, the 3 and the 12, right? And the numbers that you read in the middle are called the means. So the 4 and the 9 are the means. So the extremes are the ones on the end, the 3 and the 12. The means are going to be the 4 and the 9 in this instance. So when we solve these proportions, the product of the means equals the product of the extremes. In other words, we use this process called cross multiplication or cross multiplying to solve for any unknown quantity we might have that's in our proportion. So you can use that to determine if two proportions are effectively equal or not. So, for example, 13/36 equals 29/84. Well, we don't know if that's true. So what we're going to do is we're going to set them equal to each other. The product of the extremes, set that product equal to the product of the means, and let's see what we get. So here we get that the 13 times 84 is going to be 1092. The 36 times the 29 is 1044. Since those two things are not the same, then I know that those two proportions, or that single proportion with two different fractions, those are not the same. Okay. We can do the exact same thing when we don't have a when we don't have a value for one of the missing pieces. So that'll help us determine what that missing piece is. So if you look, suppose I have a proportion x/18 is equal to 7/9. What I'm going to do is I'm going to take the x and the 9, multiply them to get that product, and the 18 and the 7, multiply those two together using cross multiplication to get that product. And what we do when we work this whole thing out, we see that the 9x divided by itself, 9, we can divide both pieces of that equation by that same value. And as a result, it simplifies down into x equals 14. So it's really nice, very convenient. Okay, let's go ahead and jump into some problems. Go ahead and switch here to the whiteboard. Here we go. All right, so I've got a bunch of problems here, and we'll go through them one at a time. Find the means, the extremes, the product of the means, and the product of the extremes. Okay, this kind of sounds like a sign, like a like a wrap in a way. I've got 1/2. This is equal to 3/6. Okay, so what I need to do is the means. The means in this case are going to be 2 and 3. Remember, it's just the bottom and the top of the second one. Bottom of the first, top of the second. The extremes. This is going to be 1 and 6. The product of means is just going to be 2 times, whoa, what is going on with my handwriting here? 2 times 3. 2 times 3. There we go. 6. And then we have the product of the extremes. And this is going to be 1 times 6, which is equal to 6. Okay, similar problem. Let's go ahead and take a look at question 4. So suppose I have x over 3 is equal to 6 over 9. It's the same kind of process. So the means in this case are going to be 3 and 6. My extremes are going to be x and 9. So it's going to be just the unknown quantity. Even if there's an unknown quantity right there, you're still going to be using it as an extreme. So the product of the means, which I'm just going to call this for shorthand, is going to be the 3 times 6, which is equal to 18. The product of the extremes is going to be x times 9, which is equal to 9x. Okay, so these right here are all my answers in these cases. All right, so let's go ahead and jump into the next question. Now here what I need to do is I need to determine whether or not the pair of ratios are equal. Okay, so suppose I've got, what is this, 2/3 equals 10 over 15. So what I'm going to do is I'm going to cross multiply across right there. And I've got 2 times 15 equals 3 times 10. So 30 is equal to 30. So that's true. So in this case, both of the original fractions that I first initially started with, those are actually perfectly equal. They're exactly the same. All right, let's do another one. Suppose I have this guy. We'll do 9 3/5 and 18/20. I think the question is actually more, the way they show it or they set it up is with this comma, and you have to set them equal to each other to figure out if they are actually equal. It's kind of weird. You're doing the thing that you're not sure is true. You're setting them equal to each other. So 3/5 and then 18 over 20. Okay. And so again, the same process, we'll cross multiply. So 3, whoops, let's go back, do this correct. 3 times 20 is equal to 5 times 18. And we're going to get 60 is equal to 90. Okay. And this is very clearly false, right? As far as I know, we have not been able to demonstrate mathematically that those two numbers are exactly the same thing. So this is false. All right, let's go ahead and do some kind of solving. So if we're given a proportion with an unknown variable, we have to figure it out. How do we proceed? So in this question, we're going to solve the proportion. And we've got 1 over, say, a quantity of A. This is equal to 4 over 16. Okay. And again, the process is exactly the same as what we just did. We're going to cross multiply this. So I've got 1 times 16 is equal to a times 4. Or you can write this as 16 is equal to 4a. What we're going to do now is, because I've got a coefficient in front of this a term, I'm going to divide both sides by that same value. And what happens is these two things cancel out right there. Well, I shouldn't do it on the back end. So 16 divided by 4, I know that's equal to 4. And so in other words, a is equal to 4 here. Let me redo that. 4. There we go. So that's my answer. All right, let's do another one. 21. So we've got 5 over 7 is equal to 3x over 14. Five times 14 is equal to 7 times 3x. And the 5 times the 14 here, this is going to equal 70. On the right-hand side, we've got 21x. So we can divide again by the coefficient in front. And in this instance, we're going to get that x is equal to 3.3 repeating. So that's kind of what the bar means. I don't know if you remember talking about that a while back, but the bar means the 3 repeats forever. Or another way of writing this would be 3 1/3. Okay, or you can do it as an improper fraction. This would be 10/3. Okay, any of those should be completely sufficient. I'm not sure how the homework probably would want you to put it in. I'm guessing probably in this form right here is what the homework is going to ask for, but I don't know exactly for sure. I'm guessing that's probably where you'll have to go. Okay, now to the application questions, because these proportions really are valuable for applications. I remember a while back, my parents were trying to lose some weight, and they were competing with each other. But they did it in kind of a really crude way. It was like, we're just going to compare how much weight we lose. And I'm like, that's kind of silly, because my dad is 6'1" and my mom is 5'3". So it makes sense that my dad would lose a lot more weight than my mom. And so I remember setting up a proportion to illustrate the percentage of weight that they lost rather than the amount. Needless to say, my dad was not very happy with the ultimate results, because it turns out my mom lost a significantly higher percentage of weight than he did, and so he was pretty angry. But that was the way that it worked out. So these are very valuable when you're comparing relative quantities with one another. Okay. So in this question, I've got a builder is selling an 1,800 square foot house for $171,000. So the question is, what would be the price of a 2,400 square foot house? So I want to point this out. There's actually two ways to set this up. And this is this is the same question. You can kind of pull it up. I'm not going to write out all the words and everything, but if you want to pull up the question in the textbook, you certainly can do that. There's two ways to set it up. I can compare the 1,800 square foot house to the cost. And then I know that the 2,400 square foot cost is going to have its own, or 2,400 square foot house is going to have its own cost, but I don't know what it is, so I'm going to use that as a variable. Or the other way to do it is to associate the square footages with each other, and then on the other side, you're associating the price with each other. So the smaller one first, and the bigger one last. But you'll notice really quick when you do the cross multiplication in both cases, you get exactly the same answer. So I normally tend to go this route because it follows the order of the way that it's described in the question, and I generally want to keep it roughly the same. So in this case, it's 1800 times x is going to equal 2400 times 171,000. It's pretty large. This is going to be a large number. I'm just going to tell you right now. So here we get 1800x. This is going to equal 410 million. Let me try this again. 410 million. Okay. And now all we have to do is divide both sides by 1800. And we'll get x is equal to, in this case, 228,000. So a square footage, if they're roughly the same house, but a square footage increase of about 600 square feet should yield a cost of roughly 228,000 compared to 171,000. But, you know, all houses aren't the same. I guess that would be like if you guys don't really have this in Kansas. In New York, where I'm from, we have something called patio homes. They're basically they're like tiny little neighborhoods that are all effectively the same house. And so it would make sense in that kind of model home setup. You could kind of scale it pretty easily. I haven't seen them in Kansas. Maybe they are in Kansas. I just don't know. You know. All right, let's go ahead and do another question. And this will be the last one for the section. Question 49. Question 49, it says that a plane flies for 3 hours and uses 25 gallons of 100 LL aviation fuel. How much will be used if the plane flies for only 1.2 hours? So here is the important thing about this question, okay? The 100 LL aviation fuel is just like an added number that makes no difference in this question. It's like a brand. So the important thing is the 3 hours using 25 gallons of fuel, and we have to figure out how much fuel is used if it only flies for 1.2 hours. So our proportion will be set up like this. I've got 3 divided by 25, and that is going to equal 1.2 over x. All right, so we can cross multiply this, and here we're going to get 3x is equal to 25 times 1.2. And when we work this all out, we actually find that this is going to be, I'm going to have 3x is equal to 30, and we can just divide by 3. And these all cancel. So x is going to equal 30 divided by 3, which is equal to 10. So in other words, this is going to be, what? This is how much fuel will be used if the plane flies for only 1.2 hours. This is 10 gallons, I should say. All right. All right. So if you have any questions, don't hesitate to let me know. But that's all we have today. So I hope you have a good one.